is actually going to be related to next week's lab, but I want to talk to, next week is our last week, is that correct? Yeah. And I'm going to have a lab next week that I'm not going to collect, but it's going to be a little bit like, what I want to talk about that there. Well, there's a question on the final exam that's basically it's a story type problem, and I'm not going to give you that question, but I'm just going to say I'm going to make up a question there and kind of explain the question here, and I'll let you go shortly thereafter. I know we're near the end, not many of us here there, yeah, but I don't want to waste the hour either, that there. So let me throw a scenario at you, or throw a problem at you, and I want you to kind of think about this problem there. Let's say I've got a tank of water right there. No, in other words, I've got a tank of water right here. And this water has to be kept between 80 degrees C and 75 degrees C right there. In other words, that's the temperature of this water right there. So, and again, this is not unlike what you would see in a real life problem right there. I have two sensors in this water tank. Sensor 1 goes high if the temperature is greater than 80 degrees C right there. Sensor 2 goes high if the temperature is less than 75 degrees C right there. These are both temperatures in C. Now we also have to assume that we also have a heater right there, and we're going to assume this tank of water is someplace in Malaysia that there, and the ambient temperature is definitely below 80 degrees C, right? I mean, 80 degrees C is pretty warm right there. So if we were talking Fahrenheit, the temperature in Malaysia is quite often higher than 80 degrees Fahrenheit, but Celsius, we don't have to worry about that there. So we don't need a cooler right there. So essentially, you're asked to design a program, a system that there is to make this happen right there. And again, this is similar to a problem on the final exam, and it's a problem toward the end of the final exam where the problems tend to get more difficult there, and the expectation is that most people will not finish this problem, but it's the one that determines the really good students for there. But let me just kind of throw this type of problem at you so that you've seen something that looks like that. So our heater, again, and I'm going to, just to make grading easy on myself, I'm going to say that sensor 1 is on port 1.0, sensor 2 is on port 1.1, and the heater is on port 0.1 right there. In other words, I'm just saying what ports these are on right there. So in terms of hardware, there's nothing to do. I've already done the hardware design right there. I'm not requesting that you design the analog circuitry to read the temperature sensor, to go through and set up the relay to turn the heater on or off, or any of that stuff there. All we're going to do is that there, and it's a fairly straightforward problem right there, is that when port 1.0 goes high, turn off heater. Right there. Now the problem will be worded up to this point. In other words, everything I'm going to say now is part of your answer right there. So all I'm saying, the question is, you have a vat of water that needs to be kept between 80 degrees and 75 degrees Celsius. You have two sensors. One sensor goes high if the temperature goes above 80. One sensor goes high if the temperature goes below 75, and you have a heater right there. The sensor 1 is on port 1.0, sensor 2 is on port 1.1, and the heater is on port 0.1 right there. Write the program to make this happen right there. So, your answer right there, and I'm going to just throw this out here as a homework problem / next week's lab that you have to write this. That there, we have two push buttons that we can use, and we have an LED for the sensor that there. We can push our buttons that there. So when the temperature when the temperature goes high, or when port 1.0 goes high, we turn off our heater. When port 1.1 goes high, and I can't spell here, goes high, turn off the heater. We can assume that port 1.0 and port 1.1 cannot be high at the same time. The reason we can assume that is by definition, we said that sensor 1 goes high if the temperature is greater than 80. Sensor 2 goes high if the temperature is less than 75. So the temperature can't be greater than 80 and below 75 at the same time. If both sensors are low, we can assume that the temperature is between 75 and 80 right there. So in terms of what we're going to see, that there, here's our temperature right there. If the temperature goes above 80, then this is 80 degrees right there. Then sensor 1 goes high right there. We turn the heater off. The temperature starts to go down. We reach 75 degrees right there. As soon as we get below 80, this goes back down again right there. There. As soon as we get to 75 degrees right here at this point, this temperature goes high. We turn the heater on, so this temperature goes low again. The heater stays on until the temperature gets to 80 again. Then this goes high right there. So we're going to get these pulses right there. The temperature drops right there, and actually the temperature actually is going to go up like this, and it's going to go down like this right here. And when we reach 75 and 80, we turn the heater on or off right there. So that's what we're going to have happen. So basically what we're going to be basically doing is we're just going to go through a little loop right there. And again, this is relatively straightforward. What we're going to do is we're just going to simply start off that there, and we're going to just call this start right there. Now, the beginning, let's first off kind of let me explain what needs to be in your answer right there. The first thing we need to do is we need to initialize the port. Now, I will tell you that Blinky will be included as part of a sample program to look at that there. But we have to set up, first off, what we need to do is we need to set up port 0.1 as push-pull right there. And we also need to turn on the crossbar. Right there. Right there. We need to do those two steps up there. So our code is going to start off when we look at main right there. Right there. First thing we're going to do is we're going to call a net port. And we'll talk about a net port here in a minute right there. Then what we're going to do then is we're going to just simply there, we're going to do a jump not right there, and I just drew a total blank. Let me pull up the instruction set. You have to remember the instruction set. I don't necessarily remember off the top of my head, but right there, desktop. Right there. I can find here it is. The instruction set right there, and the command that you want to remember, that there. This is the call. No op. All right, not 0. It's the exchange, jump no carry, jump bit right there. So this is the command that you want right there. Because what we're going to do is we're going to look at this particular bit. If it's set, we turn on the heater right there. If it's not set, we don't turn on the heater. So we'll probably use the jump not bit right there. And the reason right there, so this jumps the address indicated by destination bit is 0. Otherwise, that there. So example, jump not bit, ACC.6, comma array 1, jump not bit right there. That just simply tells it to branch to a location right there. And the reason I brought this instruction up is that there. And then I also wanted to point out that we'll come back to that there. Let me bring Blinky up right here. Right there. Open with Notepad right there. And the reason I brought Blinky up is that we've got a couple of commands that we can use from that there. Mainly, the main thing is we want to enable the crossbar right there. And we want to set our ports to push-pull right there. So we want to steal those commands from Blinky right there. So, all right. Getting back to our problem right there. Right here. So we jump. And what did I just do right there? Jump no bit. And we're going to look at, first off, let's test to see whether we want to turn the heater off, right? Right there. So if S2, which is on port 1.1, right there, do not turn off. And you can make this label here. And we could say clear port 0.1. This is turn off the heater. We can do a jump no bit port 1.0 right here, and this is our do not turn off right there. Let me just put our label right here. Do not turn off right there. Is shorten that there, right there. Jump it right there. Do not. I should put F right there. F right there. Do not turn on right there. Turn on right there. Set bit port 0.1 right there. Do not turn on. Same label right there. Jump start right there. Start right there. That's the entire program essentially right there. I'll let you look at it. I may have made a mistake there, but that's essentially all you want to do is you just want to look at those pins and determine whether or not to turn the heater on or off. Don't make it any more complicated. So we got one more thing to do. We have a function right here, a init port right there. And the first thing we want to do is we want to move right there into, and again, you're going to have this program available or something like that right there. Actually, this is our, well, we can do it right. We can just simply use that right there. We can just copy those two lines right there, essentially, right there. Right there. We can, I don't think those are the ones that we use right there, but let's just move, and we're going to say X bar XBR2 comma 40H, turn on our crossbar, and we can do it UR or mode 0, mode N, actually digital output right there. We're going to do 01H and RORL mode 0, mode out 01H right there, and then return right there. And that's the entire program. Now I'll let you worry about, look at that there, but keep in mind that if you see something like this, you have to go through and include all the things here. And probably the other thing you might want to do in here is we might want to turn off the watchdog timer right there for completeness right there. Again, that code is right here. There's our watchdog timer right there. And you don't have to do this in a routine, but right there. Well, we could use Blinky right here, and this would be where we would put our code as our main part of that right there. But what you need to be prepared on the final exam is how do you start this problem right there. You have a very simple problem that there, it sounds very complicated, right? You have a tank of water, you have two sensors, you have a heater, you need to keep the temperature between a certain range right there. How do you do it? Right there. Once you think about this problem, it's not that difficult. Now, it's not going to be this problem, but it'll be something similar to this right there. And I was reviewing the final, I looked at that, and I said, I probably ought to give you a little hint that warning that this is coming right there. I have not done anything like this in class where I'm throwing a story problem at you and that there, and I'm just saying that one of those is going to be on there. So, you know, let me just throw this as an example. It may be something as simple as just turning an air conditioner on or off. It may be something as complex as keeping the speed of a motor within a range that there. But there's going to be a story problem on the final exam right there. And I can tell you right off the top that's worth 10 points right there. So again, the whole idea is that to pass the course, you need at least a 60 on the final exam, or you need a 60% overall. And I've given pretty much all the points other than the final exam. I've given you almost 40 points, so you could actually pass this course getting about a 25 or 30 on the final exam. So I'm not going to fail anybody on this problem, but I could prevent a few people from getting A's in the course. And that's really what this kind of problem is designed for, to be quite honest. When I write final exams, I start off, usually the first few problems are easier, and then they get more complicated as you get through the exams. And the whole idea is that when you get to problem 5, there's 5 problems on that there. The last part of problem 5 is really designed that probably 2 or 3 people out of the class will get it right. That there. I mean, it's a problem that is not designed, and it's not necessarily material that I covered in class. Right there. You know, when you look at one of my finals, Don't go through and read it and expect to know how to answer every question, because some of those questions I did not cover 100% in class. Everything you need to know to answer the problem was covered in class. What's missing is the part where you have to look at the problem and figure out how to apply what you learned in class. Right there. And that's the difference between memorizing the material and understanding the material. If you memorize material, you'll still pass the course, even if you don't understand the material. But if you understand the course, then you'll pass the course with an A or a B easily. Right there. If you just memorize it, yeah, you'll get a B or a C. That there, you almost have to be comatose and not show up to class at all to get an F or a D in this class. It's not designed to flunk anybody. That there, but to get an A in the course, you would have had to understand most of the material. Right there. I think last semester, probably 20% of the class might have gotten A's. Which is a pretty high percentage, actually. That there. I have taught this class in the past, and this is, with students that really, really were motivated and that really understood programming, and I've given 80% A's. That there. So 20% A's is actually a low number for me. Right there. I have taught this class where I have actually taught the class once or twice where I've given 95% A's. One person out of 35 didn't get an A. And that was a person that just didn't try that there. So it's not, as you study for the final, and I know we got another week and there'll be one more review for the final between now and then. I'm debating whether to have it. When's our next class right there? Tomorrow? Okay, tomorrow. Okay. Yeah. I'm debating whether to have it tomorrow or I think I'll do the review for the final once more tomorrow. I'll go through the final exam again once more tomorrow. And then next Wednesday we'll do the lab, and then next Tuesday we'll do this lab right there. And it's a relatively simple lab. It's just what I wrote up there right there. I'll rewrite it up again as a short little question. I'll post it on Facebook between now and next Tuesday. That there, and then the final exam review will be tomorrow, and then I think I'm going to reserve next Wednesday as just a question and answer period. In other words, I won't have anything planned, because that's our last meeting is next Wednesday, right there. So today I just want to throw the problem at you that I have not told you about this problem before. That there, I am posting this lecture up on that there for those who did not show up. That there, but short class today. That there, 23 minutes. That there, but the lecture, next week, be prepared to do this lab. And the reason I want to do this lab next week is, even though I'm not going to collect it, you've got you should have everything turned in to me by now, right? If you owe me lab 2 still, I need that by the end of tomorrow. That there, anything that's not turned in yet, turn in by tomorrow, okay? And that's for those who are not, that are not here. That there, but tomorrow's lecture is just going to be a review for the final. Right there, it'll be probably fairly short. I've covered everything that's on the final except for this one problem, and I was not going to cover this problem. I was going to leave it hang there and not tell you about it. That there, and I thought, well, I'll just give you a heads up that it's coming. That there, that there, and then next week I'll let you do the lab that's similar to the test problem, right there. That there. So that there, and I'll explain the rest of the problems that there. I think I'm going to let you go. Those of you that are here, you came and got me and said, "Is there class?" And I come down here. There's only 4 of me down here anyway. I just realized toward the end of the semester, people stopped showing up. That there.